Hi students, now we are going to solve the numerical problems from the textbook exercise in the CBSE. Chapter 1 is electric charges and fields. So in that first problem, what is the force between two small charged spheres having charges of 2 into 10 power minus 7 coulomb and 3 into 10 power minus 7 coulomb placed 30 centimeter apart in air? So it is a very direct numerical problem which is to be asked in either 2 marks or in multiple choice question. So in the picture you can see there are two charges, Q1 and Q2. Their magnitudes are 2 into 10 power minus 7 coulomb and 3 into 10 power minus 7 coulomb. So both are positive charges. So these two charges experience a repulsive force and they will be repelling outward. They are separated by a distance of 30 centimeter in air. So in which medium they are situated is air. The distance in meter is 0.3 meter. So what is the Coulomb force? We are going to find out. So we are going to apply Coulomb's law. So what is the statement, the mathematical expression of Coulomb's law? The magnitude of the force, okay, the magnitude of the force is F. So this is equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by R square. This is the magnitude of the electrostatic force between the two charges. Now in air, epsilon naught is called as what? The permittivity of free space. And if you substitute the value of epsilon naught and multiply by 4 pi, then 1 by 4 pi epsilon naught, the value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9. Okay. So 9 into 10 power 9 and the unit is Newton meter square per Coulomb square. This is the standard value of the constant. Sometimes we represent that 1 by 4 pi epsilon naught as the symbol K. Okay. So this is the value. Then what is the value of Q1? Q1 is 2 into 10 to the power of minus 7 coulomb. And Q2 is equal to 3 into 10 to the power of minus 7 coulomb. The distance between them is denoted by the symbol R. So R is equal to 0.3 meter can be written as 3 into 10 to the power of minus 1 meter. In any way we can substitute that. Therefore, the magnitude of the force F is equal to 9 into 10 to the power of 9 in place of 1 by 4 pi epsilon naught into Q. Q is 2 into 10 to the power of minus 7 into Q2 is 3 into 10 to the power of minus 7 whole divided by R square. So whole divided by R square is 3 into 10 power minus 1 the whole square. So this is 3 into 10 power minus 1 the whole square. So this is now equal to 9 into 10 power 9 into 2 into 3 is 6. So this is 6 into 10 power minus 7 into 10 power minus 7 will become 10 power minus 14 divided by 3 square. 3 square is 9 into 10 power minus 1 whole square will become 10 power minus 2. So like this easy format I have written. This 9 and 9 can be cancelled. Okay, this 9 and 9 can be cancelled. What is remaining is 6. So this is 6 into, now the positive power is 10 power 9 into remaining power is 10 power minus 14 into this 10 power minus 2 comes up as 10 power plus 2. So this will become 10 power plus 2. So this is now equal to 6 into 10 power minus 14 into 10 power 9 plus 2 is 11. So this is equal to 6 into 10 to the power of minus 3. So the magnitude of the force between the two charges F is equal to 6 into 10 to the power of minus 3 Newton. Since these two charges both are positive charges, what should be the nature of the charge? The nature of the charge must be repulsive. So this is a repulsive force. This is a magnitude. So the forces, this positive charge will try to move outward with the force F, and this positive charge also will move towards the left with the same force. So equal force but opposite direction. They are being repelled away from each other. Have you understood? I hope you must have understood well. Fine.